Have you ever noticed how the moon is following you? Let me explain. As you're traveling, objects seem to move at different speeds. The trees by the road rush by quickly, while the buildings and mountains in the distance appear to move more slowly. This optical illusion is known as parallax. Parallax is the apparent change in an object's position when viewed from two different vantage points. The further an object is, the less it appears to move in our field of view. The tree, being closer to the road, has the greatest angle of head turn and appears to move the most in our field of view. The mountain, being the furthest, has the least angle of head turn and appears to move the least. Now, let's consider the distance between the Earth and the moon. Even if I were to travel across the Earth while looking at the moon, the angle subtended would only be about 2 degrees. This negligible angle is what gives rise to the illusion. The moon is positioned at such an immense distance that despite your movement, its apparent position relative to you barely alters. Consider a simplified diagram. As we move from point A to point B, the angle subtended by the moon changes. This change in angle, denoted by theta, can be calculated using the tangent function. Suppose the car moves 31 meters and the distance to the moon is 4 times 10 to the 8 meters. Plugging these values into the formula, we get this. This change is so small that to the person in the car, the moon appears to be in the same position. I encourage you to pause this video and think about this on your own. Okay, we're back. This concept of parallax is not just fascinating, it's also incredibly useful in astronomy. Some stars appear to move slightly relative to other stars. These stars are just closer than those that don't seem to move. If we measure how much a star moves when the Earth does one complete trip around the sun, we can use this to work out an angle called the parallax angle. If we observe a star when the Earth is at one spot in its orbit and then wait 6 months for the Earth to move around the sun to the opposite point along its orbit and observe the star again, we can measure this angle. Knowing the distance from the Earth to the sun, we can work out exactly how far the star is. This allows us to accurately calculate the distance to nearby stars. Now that's a breakthrough.